weighing 10 pounds, stretching spring a quarter foot. The mass is removed and then replaced with the mass 1.6 lux. Okay. Initially released from a point 1/3 foot above the equilibrium position and downward velocity. According to this set of information, the first part gonna help you find the K. Okay, the first part here to find the K from F equals K times X. The force say 10 pounds. K stretched like 1/4 foot. The unit already good, right? So then K is 40. K is 40. And then the next one after that this partly the mass is removed misspell, sorry for my English, and replaced with a mass of 1.6 lux. So this one will be the m that we use in the equation. So from m x double prime plus k times x equals 0. So no damping force, no external force. That means just two plane terms or the homogeneous situation. So m here is 1.6. So we have 1.6 x double prime and the k, which is 40 x equals 0. What else did we know? The initial position, okay, x at 0, initial position here. Above mean opposite way, right? Above gonna be negative sign equals negative 1/3. And then x prime or the initial position, this is downwards, opposite sign again, gonna be plus sign for the initial velocity. So x prime at 0 is 5/4. All right, question? Now we got the equation set up, that's it. And then the rest, well, I'm sure you guys are more comfortable with this now. And to make the problem cleaner, again, divide all by 1.6. So we get x double prime plus 40 divided by 1.6. We get 25x equals 0. And then with the auxiliary equation, m squared plus 25 equals 0. So the m gonna be plus minus 5i. Right? I try to avoid using the same m again. So from the auxiliary equation, we get, so the auxiliary equation, we get m equals plus minus 5i. Okay, or the characteristic equation. Therefore, the general solution gonna be, or the equation of motion. That's the name of this equation of motion. X at t equals c1 cosine 5t plus c2 sine of 5t. Okay, and then follow the same process. I'm gonna keep it short and give you the C1 and C2. So C1 equals, so we can move on to other two cases. So C1 is negative 1/3 and C2 we get 1/4. Okay, then we get the solution in the form or the equation of motion. That is part A. Okay, part of the part A, the equation of motion in the form of x at t equals negative 1/3 times cosine 5t plus 1/4 times sine of 5t. And part A asks you to write in the alternative form to find the parameters for the alternative form. The A or the amplitude, which is the square root of c1 squared plus c2 squared. The square of negative 1/3 plus the square of 1/4. That will give us 1/9 plus 1/16 or 25/144 or 5/12. Okay, you can work on the detail of algebra later if you are curious how I get that fast, but I have my notes, that's why I can cheat. So the A or the amplitude is 5/12. And now we're gonna find the phi or the angle to represent the phase shift or the first position, the first first position of the first cycle. So the phi is the inverse tangent of the C1 over C2. This time the C1 is negative, C2 is positive. The 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 top one is the y value, the bottom one is the x value. So we are looking for the quadrant that the order pair has plus sign for the x minus sign for the y, which is the fourth quadrant. The fourth quadrant. Okay. Use the calculator. It will give you negative 0.927, which is already in quadrant 4. So we don't have to adjust or modify anything. Okay, it's already in quadrant number 4. All right, so quadrant 4. So there are little sensitive things within the problem. That's what I'm trying to warn you. So then the alternative form of the equation of motion will be x at t equals the 5 over 12, which is the A, multiplied by psi of the omega, which is the 5 times t minus 0.927. Okay, that's the answer for part A. Part B asks you to find the point of times, which is t, point of time t, that the displacement is at the position below. Below means plus sign. Below the equilibrium position, numerically a half of the amplitude. When x equals a half of the A, which is a half of 5 over 12 or 5 over 24. So that's the key of part B. Questions? Okay. That means the alternative form is more convenient to find the answer or the time, the point of time that the question asks you. So in part B, we're gonna use the alternative form because it's just one single trick involved into the solution form. Okay, we're gonna find t when x at t equals 5 over 24. Okay, that's the key part of part B. So from the alternative form, x equals 5 over 24. So 5 over 24 equals 5 over 12 of the sine of 5t minus 0.927. So these two numbers simplify to be 1/2 equals sine of 5t minus 0.927. Okay. Now, you're going to have to recall how to solve the trig equation. For this, you can think about the unit circle or the angle, the special angle, let's say sine, cosine, something like that. Okay. Sine positive, note here. Note the sine value positive. The angle will be in what quadrant? Quadrant 1, definitely. Right? And what else? Quadrant 2. 1 and 2. So you're going to have the two set of solutions. The first one from quadrant 1, the second one from quadrant 2. And how to get those? Again, do one by one. So for quadrant number 1, so the angle, so we use this at an angle theta. Okay, the theta equals what angle that the sine is 1/2? 60 degree or 60 degree or 30 degrees?
Is pi over 3 60 degrees?
It's
No, okay, no, it's 30. I'm sorry.
it's
You're
30
right.
degree. It's
Yes,
30 degree or
pi
pi
over 6.
over 6. Pi over 6. Okay, pi over 6 in quadrant 1. And that means the pi over 6 equals 5t minus 0. I write it this way, opposite way. Thank you, David. So that means angle theta, which is 5t minus 0.927 equals pi over 6 for quadrant 1 set of the solution. For quadrant 2, angle theta 5t minus 0.927 equals,
So it'll be 5 pi over 6, right?
yep. So this one gonna be, because it's from pi minus pi over 6, which is 5 pi over 6. So 5 pi over 6. So we have two sets of solution. The first one gonna be, we solve for t as a algebraic procedure now. So t equals, so it'll be pi over 6 plus 0.927 and all divided by 5. So I multiply by 1 over 5. Okay. And then you're gonna get, well, this is just the first revolution of first round, right? Going to be first round. So this is supposed to be pi over 6 plus 2n pi. And this is plus 2n pi. And when this one going to be plus 2n pi divided by 5. And the second term going to be t equals similar way 5 pi over 6 plus 0.927 1 over 5 and then plus 2n pi divided by 5. And then when you pick like one, what do you call, for one, for the first one, for n equals 0, for n equals 0, or just the first revolution, so gonna be just these numbers or these numbers. And then we get t for the first point of time would be 0.2902. And then the next one gonna be at 0.7 091. Okay, let's see. Oh, I have a lot of room here. I provide. There you go, the graph. So the first point, see if I can expand it out. So based on the description of this problem, let's do it one by one. Initial condition, x at 0. So that's x at 0. X at 0 equals negative 1 over 3. Okay, with the initial velocity 5 over 4, which is downward position or positive. So it's gonna be going that way. So the x prime at 0 equals 5 over 4. Okay, and then the phase shift, which is the beginning part of the first cycle, which is around there, 0.927 something, or close to 1. And then that's the initial, actually this is the initial position. So initial position. And then what else that we know? The time that the mass attained displacement below the equilibrium position. Below means positive, right? So 0.2903. So 5 over 12. So this is 5 over 12 and a half is going to be somewhere around here. So this is 5 over 24. And that's the point of, this is the point of time that the displacement is a half of the amplitude. The first is at 0.29 and the next one is 0.7. And then this is the first cycle. And then the next one, you just add it by 2n pi over 5, 2n pi over 5, 2n pi over 5, and so forth.